I'm Dr. Binu. In Artificial Intelligence and Machine Learning Fundamental Subjects, the fifth topic in the second unit is Constraint Satisfaction Problems, simply called as CSP. Standard Search Problem. Here state is a black box. Any data structure that supports successor function, heuristic function, and goal test. CSP. State is defined by variables xi with values from domain di. Goal test is a set of constraints specifying allowable combinations of values for subsets of variables. Simple example of a formal representation of language. Allows useful general purpose algorithms with more power than standard search algorithms. The best example for constraint satisfaction problem is map coloring. Here the Western Australia, Northern Territory, South Australia, Queensland, New South Wales, Victoria, Tasmania. Here the variables are represented as WA, that is Western Australia is represented as WA, Northern Territory is NT, Queensland represented as Q, New South Wales represented NSW, Victoria represented as V, South Australia SA and Tasmania T. The domains are DI of red, green, blue. The constraints are adjacent regions must have different colors. Example, WA not equal to NT or WA, NT in red, green, red, blue, green, red, green, blue, blue, red or blue, green. After the constraints, we are getting the solutions like this. That is, the Northern Territory is represented as green color. South Australia is a blue color. Western Australia is red color. So there is no two colors are located in adjacent. Then Queensland is represented as a red color. New South Wales again green. Victoria red. Tasmania green. So overall, all the solutions are complete and consistent assignments. WA is equal to red, NT is equal to green, Q is equal to red, NSW is equal to green, V is equal to red, SA is equal to blue, T is equal to green. The varieties of constraints are unary constraints involve a single variable, that is SA not equal to green. Binary constraints involve pair of variables, example SA not equal to W. Higher order constraints involve 3 or more variables, example cryptarithmetic column constraints. What is the use of this constraint satisfaction problem? Which improving backtracking efficiency. General purpose methods can give huge gains in speed. That is, which variable should be assigned next, in what order should be values be tried, can we detect inevitable failure early. Like this, we can, by asking the questions and providing the solution, we can improving the backtracking efficiency. Most constraint variables are choose the variable with the fewest legal values. Example, minimum remaining values, that is MRV, that is the heuristic one. Tiebreaker among most constraint variables. Here the most constraint variable is choose the variable with the most constraints. Least constraints variables. Given a variable, choose the least constraining values, the one that rules the fewest values in the combining these heuristics makes 1000 kinds feasible. That is, allows one value for SA and allows 0 value for SA. Local search for CSP. Hill climbing, simulated annealing typically work with complete states that all variables assign. To apply constraint satisfaction problems, allow states with unsatisfied constraints. Operator reassigns variable values. Variable selection, randomly select any conflicted variable. The value selection by min conflict heuristic. The example for constraint satisfaction problem is 4 queens. The state is 4 queens in 4 columns, so there are 4 to the power of 4. There are 256 states. Actions: move queen in columns. Goal test: no attack. Evaluation: h of n is equal to number of attacks. And the first diagram represents h is equal to 5, second one 5, h is equal to 2, third one h is equal to 0. Given random initial state can solve n queens in almost constant time for arbitrary n with a high probability of n is equal to 12, that is 10,000 10,000 times. CSP or special kind of problem. Here states defined by values of a fixed set of variables. Goal test defined by constraints or variable values. Backtracking is the depth first search with one variable assigned per node. Variable ordering and value selection heuristic help significantly. Forward checking prevents assignments that guarantee later failure. Constraint propagation, that is, our consistency does additional work to constrain values and detect inconsistencies.